Assalamu alaikum. Today we are going to start the mathematics of class 9 unit number 1, which is matrices, and exercise 1.3. There are two parts for this video, the first part and the second part. So this is the first part in which we would do question number 1 to question number 8, and in the second part we'll do question number 8 to question number 14. So let's start. Before starting the exercise, we should do some learn some concepts. The first basic concept about matrices is addition of matrices. So addition simply means adding one matrix to another matrix. There is a rule for adding a matrix. Actually, two matrices are able to be added when their orders are the same. For example, if we take matrix A, which is a square matrix, so it's a square matrix. This is just an example. And matrix B, which is also a square matrix. So these two can be added. So A plus B is possible. So A plus B is possible. But if the orders are not the same, then they are not added. So they cannot be added. For example, if we take a 2 by 3 matrix plus 2 by 2 matrix, so the orders are not the same. So they cannot be added. If you don't know about orders and these things, so you must watch the first lesson of this chapter, so you should understand that, and then come to this video and watch these all concepts, so you would understand better. So this was the first concept. The second is subtraction of matrices. So subtraction of matrices is actually always also the same. It has the same rule. If the order is the same, then it can be subtracted. Let's have an example. First of addition and then for subtraction over here. So let's just insert a bit space. So if it's 1 0 0 1, let's have an example first. Minus 2 1 3 0. So this can be subtracted because this is a 2 by 2 matrix and this is also a 2 by 2 matrix. So these can be subtracted, so this is possible. Let's move on to the next concept, which is multiplication of a real number into a matrix. So real number, for example, real numbers are 1 2 3 4, or any number or any else number. So if we multiply any of these real numbers by a matrix, that's very easy. That's simple multiplication. For example, if we take an example, 2 into a matrix, so 2 3 4 5 and 6 7. So multiplication is simple. Just multiply it with all the elements of this matrix, all the elements of this, sorry. So if you multiply it, it would become 2 into 2 is 4, 2 into 3 is 6, 2 into 4 is 8, 2 into 5 is 10, and similarly 2 6 are 12, and 7 is 14. So simple multiplication. It's very easy. You must remember these concepts in order to understand all the questions of the exercise. So let's enter the exercise. Let's start the question number 1 for exercise 1.3. Question number 1 says, let A and B be 2 into 3 matrices. So matrix A is a 2 by 3 matrix. Similarly, matrix B is also a 2 by 3 matrix, so 2 by 3. And let C and D be 2 square matrices. So let C and D be, oh sorry, the spelling is here is wrong. It's wrong, sorry. And C and D be 2 square matrices. So square, we know the square matrices have a same order, and that's 2 by 2. So for example, this is C is 2 by 2, and D is also is also a 2 by 2 matrix. So which of the following operations are defined for those which are defined and give dimension of the resultant matrix? So the first question here is a plus b, a plus b. So we know that for addition, the first thing that is going to be the same would be the order. So A and B, the order of A is 2 by 3 and the B is also 2 by 3. So we know that A and B is possible. So we'd write the answer the addition. So addition of A and B is possible. So addition of A and B is possible. Next question here we get is part 2. Part 2 says B plus D. So B is a 2 by 2 matrix and C is a square matrix. It may be okay. The important thing is square matrix may be 3 by 3, there's 2 by 2, 4 by 4, which means the order, the rows and the columns are the same. So it's not necessary it's 2 by 2 here. It can be 3 by 3, it can be 4 by 4, it can be 5 by 5. So it's a square matrix. We just know it's a square matrix. So C and B cannot be added because their orders are not the same. So B plus D is not possible. So B plus D is not possible. By the way, we left one thing in the first part, which says that give the dimension of the resultant matrix. So the addition of two similar orders of matrices would result in the order of these two. So here A and B are 2 by 2 matrices, so the result will be also a 2 by 2 matrix. So it would be 2 by 2 matrix. Let's move to part 4. Part 3. Part 3 says 3a minus 2c. So 3a minus 2c. Let's just ignore these 3 and 2's. So ignore these 2 and 3's. It's a minus c. So a here is a 2 by 3 matrix and C is a 2 by 2 or a square matrix simply. So this is not possible. So it is 3a minus 2c is not possible. So it's not possible. Let's move to part 4. Part 4 is 7c plus 2d. So the similar thing we're going to do here, just to get rid of these 7s and 2s, it would be c plus d. So c is a square matrix and d is also a square matrix. So this is also possible. So 7c plus 2d, 7c plus 2d is possible, and the resultant matrix would also be a square matrix. So here our question number 1 reaches to an end. Let's start question number 2. The question number 2 says multiply the following matrices by the real numbers as indicated. So we simply need to multiply the given matrix by a real number. So let's start. We know that simple multiplication would occur here. So a equals, so we write 2a equals 2 into the matrix. That's 1, 2 and 3. So simply multiply this and we get 2 into 1, 2 into 1, then 2 into 2, then 3 into 2. Oh, sorry, this is 1 into 2. So it's okay, we could write this like this. So the answer would be That's 2, 4, and 6. So this is simple multiplication. You don't need to worry about this. It's quite easy. Let's do the question number 2, the part 2 for these. It's these here we don't have the real numbers, we have variables. So let's just imagine, pretend that these are real numbers, so that multiply this given matrix by p, which is a real number. So p is a real number, any real number, so we're going to multiply it with the matrix p into a, b, c, d, e, and f. So p would multiply with a, then p would multiply with b, then p would multiply with c, similarly p with d, and with all of them. And simply we would get, by the way, this is a not a capital letter P, so PA, then PB, then PC, then PD, PE, and PF. So this is the answer for question part 2, question number 2. And let's move on to question number 3. Question number 3 is find x such that 4x is this matrix. So we are given with a number, with a matrix which is 4x. So it means it's 4 times x. 4 times x. So we need to find the value of x here. We don't need this 4. So what we need to do here is, it's easy, we're gonna remove this 4 here. So we know that 4 here is multiplying with x, so we're gonna divide this 4 to cancel out it. So if we divide it, so 4x divided by 4, and then so we also need to divide it on both sides, so the other side too. We can not write it like this, simply we would write it like in an inverse. So 1 by 4 into this matrix, 1 2 1 4 2 3 minus 1 9 and 7. So this 4 will cancel out, and x would be equal to, simply multiply this 4 with every number here. So 1 into 1 by 4, then 2 into 1 by 4, 1 into 1 by 4, then 4 into 1 by 4, similarly 2 into 1 by 4, similarly 3 into 1 by 4, minus 1 into 1 by 4, 9 into 1 by 4, and 7 into 1 by 4. So it's getting a bit complex, but don't worry, we need to cancel out some of these values here. So 2 would cancel out with this, and similarly here and here. So now, okay, we write it a bit simple here. So it will be 1 by, so 1 by 4, that's 1 by 2, 1 by 4, that's 1, and it's 1 by 2, 3 by 4, minus 1 by 4, 9 by 4, and 7 by 4. So simply we get the value of x as this matrix. Next question is question number 4. Question number 4 says that if A equals this matrix and then B equals this matrix, then find 3A minus B. So here we're gonna do, what we're gonna do is actually find 3A. So 3A 3 times this A matrix. So we're gonna multiply 3 with this A matrix and then subtract it from this B matrix. So first, let's just find 3a. So if a is equal to this, then 3a would be 3a, so equals 3 into this matrix. So 1 2 3 4 5 6. Okay, we're gonna multiply this 3 inside. So 3, I'm just going to do it directly. 3 2s are 6, 9, 12, 15, and this is 6. So 3 6 is 18. So we got what we got here is 3a. Now we need to subtract matrix B from this 3. So 3a minus b, sorry. So 3a minus b is 3 6 9 12 15 and 18 minus minus 3 minus 2 1 minus 5 4 and 3. So this is the B matrix. We're simply gonna subtract it from this. So 3a minus b equals 3 minus, and then this minus with the 3 minus 3, then 6 minus minus 2, 9 minus 1, then 12 minus 15, minus 15 here, not 15, it's 5, 15 minus 4, and then 18 minus 3. So 3a minus b would equal 6, because minus minus is plus, and then this is 8. So 8, then 8, minus minus would add this 12 and 5, which would result in 17. So 17, 15 minus 4 is 11, and 18 minus 3 is 15. So our answer is this matrix. Let's move on to the next question, which is question number 5, which is quite similar to this one. Is given matrix A and matrix B, find C such that A plus 2B equals C. So we're given with equation kind of thing, and we are gonna find the value of C, which means matrix C. So here we're gonna we don't need to rearrange because C is already on the other side. So first we'd find, I think, is 2b, so multiply 2 with matrix B, this would be better. So matrix B, 2b would equal 3 into 2, and then minus 1 into 2, then 2 into 2, then 4 into 2, this into 2, 5 into 2, 2 into 2, and 3 into 2, and 0 into 2. So this would become 6, and minus 2 minus 2, then 4, then 8, then 4, 10, 4, 6, and 0. So this is our value for 2b. So 2b is this matrix. The next thing which we are going to do is add A with this matrix. So if we add A with this matrix, so matrix A is here, so A plus 2b equals 1 2 minus 3 5 0 2 1 minus 1 and 1, and then add it with this 2b. So 6 minus 2 4 8 4 10 4 6 0. So simply add 1 plus 6, then 2 plus minus 2, then minus 3 plus 4, this 5 plus 8, 0 plus 4, 2 plus 10, 1 plus 4 minus 1 plus 6, and 0 plus 1. So 1 plus 6 is 7. um, then this would be plus 2 minus 2 0. Then we'd have plus minus 3 plus 1 is 1. 5 plus, okay, so 5 plus 8 is 13. 4, 12, 5, 5, and 1. So this is the answer for C. So matrix C equals this matrix. Next question is question number 6. If A equals this matrix and B is this matrix, then find X such that 2 plus 3x equals 5b. So this is a bit complicated equation. We need to rearrange it first and then go on with just putting the values of these matrices in it. So rearranging this equation, we need matrix X. So we shift this 2a to the other side. So that will be 3x equals 5b minus 2a. Then we don't need this 3 here, so just divide it on that side. So x equals 5b minus 2a. So actually we can also write this 3 like this, but we are dealing with matrices, so I rather prefer writing this 3 as an inverse. So it would become 1 by 3. So this is our equation. So this is nothing very fancy, just don't worry about it. Simply when we just put the values of matrices here, then you would understand better. So first we're gonna find 5b and then 2a, and then subtract those both and divide 3 on them, and we will be with our answer. So 5b. So 5b is 5 into B. So B matrix is 8, 0, 4, minus 2, 3, and 6. So this is the matrix B. We're gonna multiply 5 with it. 8 into 5, and 0 into 5, 4 into 5, minus 2 into 5, 3 into 5, and then 6 into is this 6? Yep. So 6 into 5. So okay, so here is our value. So 8 5s are, this is 40. Then 0 into 5 is 0. 4 into 5 is 20. 2 into 5 is minus 10. Minus 2 into 5 is 10, minus 10. And 3 5 is 15. 6 into 5 is 30. So this is 5b. 5b. Now we're gonna find 2a. So 2a, yes, 2a. So 2 into a equals a, sorry, so multiplying 2 with matrix A, which is 2, 2 minus 2, 4, 2 minus 5, and 1. So simply multiplying 2 with it. I'm going to be a bit direct. So 2 into 4, minus 4, then 8, then 4, then minus 10, and then 2. So subtracting these both matrices, this is 5b minus 2a. So 5b 5b is this is 40, 0, 20, minus 10, 15, 30, minus this 4, minus 4, 8, 4, minus 10, and 2. And 40 minus 4. So 40 minus 4, then 0 minus okay, by the way, this is minus, so minus and then minus 4, then 20 minus 8, minus 10, minus 4, 15, minus 10, 30, minus 2. So 5b minus 2a equals 40 minus 4 is 36. Then this is plus 4. This would become 12, minus 14, minus 20, yes, plus 25, so 25, and this would become 28. Okay, so this is the value of 5b minus 2a. What we need to do next is just divide it by 3 here. This is the equation, so divide it by 3. So 5b minus 2a divided by 3 equals 1 by 2, 1 by 3, sorry. So 1 by 3, and then 36, 4, 12, minus 14, 25, 28. So simply divide it. 36 divided by 3, 4 divided by 3, 12 divided by 3, minus 14 divided by 3, 25 divided by 3, and 28 divided by 3. So I'd write the answer rather here. So answer is okay, so 36 divided by 3 is 12, then 4 by 3, then 4, minus 14 divided by 3, 25 divided by 3, 28 divided by 3. So this is the answer. It's a bit messy, but I'm sorry, I am out of space here. So it's a bit complicated, but if you pay attention, then it's very easy. So question number 7 is find x, y, z, and w if this is a kind of equation. So it's 3 this and equals this. Okay, so this kind of questions we've done in the previous exercises, so it must be easy for you. Now if we want to find x, so here we have x, which is equal to x plus 4. So by the way, this 3 is also multiplying with this matrix. We'd write it 3 here, 3 into x equals x plus 4. This is the first this is the first equation. So simplifying it a bit further, 3x equals x plus 4. Then 3x minus x equals 4. 3x minus x equals 4. 2x equals 4, and divide 2 on both sides. We'd get the value of x as, so x equals 2. So x is 2. Next is finding the value of another variable, maybe w. So w here is w equals 2w plus 3. So w so w equals 2w plus 3. So uh, okay, 2w plus 3. Okay, so uh, actually this is 3w because this 3 is multiplying with all the elements. So 3w now, subtracting 2 from both sides, so 3w minus 2w equals 3. W equals 3, so the value of w here is 3. Next is finding the value of y. So here y equals 6 plus x plus y. So 3y, because 3 is multiplying, so it's, sorry, 3y equals, so 3y equals 6 plus x plus y. 6 plus x plus y. We know that x equals 2, so and also we subtract y from both sides, so 3y minus y equals, then it's 6 plus y is x is 2, so that's 2y equals 8, and then dividing this on both sides is 2, and we'd get y as 4. So y equals 4. The next value we are going to find is the value of z. So z equals minus 1 plus 3 plus w. So z equals minus 1 plus 3 plus w. Let me check it. Z equals minus 1 plus 3 plus w. Yes. So we know that w equals 3. So z equals minus 1 plus 3 plus 3. By the way, this is 3z because 3 is multiplying. Uh, okay, so this is 3 plus 3 equals 6. So minus 1 plus 6 is 5. Sorry, not minus 5. This is 5, then 3z, 3z. So dividing 3 in both sides. So 3 and 3. And the value of z is 5. 5 by 2, sorry, 5 by 3. So the value of z is 5. Z equal 5 by 3. Here we are gonna start the next question, question number 8, which is the last part of this video. The next parts would be done in the next video. This is find x and y if x plus y equals this matrix and x minus y equals this matrix. Here we are going given equations. Let's write these equations. X plus y equals 5 2 0 9, and then x minus y equals 3 6 0 minus 1. So actually we need a single variable, and we need to remove the other one, so we could have the variable of the value of one variable, and we'd put in these equations, and we'd get the value of the other what is it called, matrix. So as the question says, find x and y, so we need to find two matrices. So I think the better way of finding it is just adding these two equations. So y and y would cancel, so we get 2x equals 5 2 0 9 plus 3 6 0 minus 1. So we'd add these both. 5 plus 3, then 2 plus 6, 0 plus 0, 9 minus 1. So 8 8 0 8, and we have 2x here, so we divide it on both sides, and we'd get x equals 4, 4, 4, and here 0. Okay, let me just erase this. And so the value of x is this. What we need to do here is put this value of x in this equation. So x plus y equals 5209. So putting the value of x here, 4404 plus y equals 5209. Subtracting this matrix from both sides, y equals 5209 minus 4404. So simply we'd subtract 5 minus 4, 2 minus 4, 0 minus 0, and 9 minus 4. So here's 1 minus 2, 0, and 5. So 5.